Hello, everyone, and welcome back to Tech Station, the podcast where we uncover the latest topics and trends in tech. I'm Valentina, technical architect at Microsoft, and today I'm with Lana. Would you like to introduce yourself?
Yes, sure. Hello, everyone. I'm very happy to be here. Thank you so much, Valentina. I joined Microsoft about 6 months ago, and I'm a technical specialist here on the data and AI team.
Amazing. Thanks a lot for being here. So today we are going to discover what happens when we put multiple AI agents in the same room, right?
Yes, exactly. So today we're talking about multi-agency, and it's a great topic today in the AI field because these agents can, integrate with other advanced systems to increase efficiency. They can automate processes. In fact, AI agents can take actions, and they can even do so explicitly without being programmed to do so. Their capabilities are what make them such a great topic today, and I think it's important to talk about it because it's kind of where the AI field is heading. It's in towards a future where intelligent agents can collaborate and they can integrate seamlessly to drive value and innovation.
Amazing. So first of all, can you explain what an AI agent is?
Yes, of course. So there are a lot of different ways to explain AI agents, but in the context that I would use them, I would describe them as the way that they can interact with multi-systems and multi-agent systems. So essentially what an AI agent is something that's programmatically done to interact with multiple data sources, and they can perform tasks automatically or semi-automatically. They process data, they can make decisions, and they can take actions to achieve specific goals without this constant human intervention or interference. For example, they can process user queries, they can retrieve relevant information in a application, and they can take actions such as updating databases or performing tasks in external systems. And these AI agents would essentially be designed to work in specified roles. They can be, as simple as a chatbot that's answering basic questions, or to more complex roles like autonomous vehicles or systems that manage workflows across multiple different platforms.
Well, that sounds very complicated. So let me try to extrapolate the anatomy of an agent in four simple components, okay? So let's start with the LLM. The first component is, of course, a large language model that acts as the brain of the AI agent, and it will understand, based on user query, which kind of other components to use, to leverage to accomplish the task. Then we have the system message. The system message, or also meta prompt, is the set of instructions in natural language that we provide the AI agent with and that are supposed to specialize the AI agent behavior. The third component is the set of tools that we provide the AI agent with. So a set of instruments, we could say like that allow the agent to interact with the surrounding world, with a third-party system, or for example, with databases or knowledge bases that we provided it with, like the example that you did before with a SQL database. And then we have a fourth component that is the memory. Memory can be defined in two ways, like short-term memory, that is the history that we keep in terms of interactions like human and AI agent interactions, so the short-term conversation that we have. But we also have a long-term memory that might be defined as, for example, a vector database where we put all our documents that want to be retrieved if we have something that it's outside the LLM knowledge, right?
Yes, exactly. I think that's such a good way to think of it. You have, that, as you said, the first component being the LLM. So that's, your foundational model, what you decide to use to generate your responses. And that can be, Azure OpenAI, that can be open source models, depending on your use case. And then, as you said, with the system message or that meta prompt, it's what you say in natural language to guide that model's output. And that can really increase the accuracy depending on your use case. And I guess if you see only these two components, it kind of looks like ChatGPT. But when you add, a set of tools, which can be for API integration, as you said, with the third-party applications, and you add a memory system, it becomes more advanced and it kind of looks like retrieval augmented generation, and having that vector database or, chat history saved so you can enhance the production and the efficiency of an application like this.
Amazing. So basically, when we talk about agentic behavior, we refer to that focus that we give our AI application or AI agent on a specific domain with a specific set of tools. And by doing so, we kind of limit the freedom of the system to the set of tools we provide it with. So for example, I could design an AI agent as a database agent or DB agent and provide it with a SQL tool so that it can only interact with my database and invoke this tool whenever it needs according to my request. Is that correct?
Yes, exactly. So if you have, whether a specified role for agents or if you have a specific knowledge base, it kind of decreases the chances of the LLM hallucinating because it's referring back to a set of retrieved documents that it's being grounded on.
Got it. And why do we need agentic behavior? I mean, beyond hallucination, why do we need it?
So, they're really relevant in industries today. And I think that I think what's most important to think about agentic behaviors is that they can be integrated into almost any existing system that's in the industry. So whether it be healthcare or finance or logistics, supply chain, any of these kind of industries, AI agents can streamline operations, they can automate repetitive tasks, they can optimize workflows. They basically can allow an organization to focus more on their strategic initiatives, and they can automate other processes, which can really increase efficiency and it can reduce human error. And I like to think of them at the most basic level is that they're just enhancing decision making, they're automating processes, as I said before. And I think that's what makes what's key in making their adoption a factor in driving innovation across different sectors, whether that be, for large industries and enterprise or just for the individual who's trying to automate their processes.
Wow, that sounds promising. And we are talking just about one single agent. Now, I'm curious to know what happens if we let multiple agents talking together and collaborating together, like giving this kind of opportunity to AI agents. What happens in this case?
So what happens is something I think that's really cool. So multi-agent systems, when you integrate multiple different single AI agents, you allow them to work together on really complex tasks. Instead of having, one agent handle everything for you, you can have multiple agents collaborating where each of them are focused on a specific task. And it makes the process more efficient and, more importantly, more scalable as well. So as I said before, when you have that process that already exists and you're integrating more AI agents, you're really scaling that simple application, for example. And I think this is really important because you can take a solution and you can extend it with multiple agents, creating something that's even more powerful. Some of the examples that I've given before, take a use case for research. You have a retrieval augmented generation system, a RAG system, where a chatbot uses, Azure OpenAI to generate responses and Azure AI Search or another search service to retrieve documents. And this chatbot is grounded on a few articles from magazines and reports from different industries. Now, if I ask the chatbot in my user query if it can create a blog post on the latest trends in the fashion industry, it may not be able to generate the most accurate information because it's not integrated with the most up-to-date information that's in the index. So the index may be outdated. And this is really where multi-agents can come in, and they can extend the RAG system by including, for example, an agent for market research that retrieves information from the public internet. So it's basically integrating with the APIs for documents on the internet. And then another agent could be tasked with, generating reports in a specific format, whether that be PowerPoint or Excel or a specific kind of template. And then you can also integrate a writer agent to generate text in also a specific writing format. And you can also have a critique agent or a critique in general to edit these reports and provide a review. And you see this example, it shows how a simple chatbot for research can be extended into a multi-agent system that would usually be taking multiple interventions between multiple different departments in an organization going just beyond basic user queries. It's providing richer, more up-to-date and formatted outputs that suits a variety of business needs, essentially unlocking advanced workflows and adding a lot of versatility to your solutions.
So you are basically telling me that I could simulate a research group where I have a market researcher, a data analyst, a writer, and a critic. And I can ask the group to write a blog post about the latest trends, for example, in the retail industry, and see the following. The market researcher will retrieve the info from the web. The data analyst will create relevant reports for me. The writer will bring them together in a nice article, and the critic will review it all.
Yes.
But I mean, is it real? It sounds like a dream. Where is the pitfall?
So it is real. And I know it does sound like a dream. Obviously, saying it and talking about it is much more, I guess, easier. In implementation, it is a bit more difficult. And you also kind of have to consider how agents will interact. So we do have to keep in mind that multi-agents are relatively new in the industry. Yes, they've been around for a while, but now as they're gaining traction, there's still some, stuff to figure out. But what I can tell you now is that there are definitely different ways to structure the workflows between agents. Like one common approach would be a peer-to-peer agent where all agents are collaborating equally. Each agent is sharing information with others and they work together without an agent that you would specify as like a leader. And this is great for tasks where each agent brings up unique expertise to the table and they need to collaborate dynamically. Another approach that you can configure is a hierarchical approach where one agent is acting as the supervisor or the coordinator, and they're overseeing the actions of the other agents. And in this setup, the lead agent is assigning tasks to the other agents that are maybe just more specified on a certain task. And it's basically completed in a sequence as like that hierarchy. So you can think of this as being useful when you have a more complex task that's a more step-to-step process and it requires some agents to manage or delegate tasks based on the bigger picture. And in this structure, it really emphasizes the agents talking to each other and collaborating. So sometimes what you see that's very common in this kind of architecture is that the output of one agent, so for example, the coordinator is summarizing the task at hand, that output, that summary is going to be the input for the other agent. And it can go back and forth, or it could just be sequential, like summary input from one agent, output from one agent is the input to another, that output is the input to another, and you see that sequence. I guess, the workflow really does depend on the complexity of your task and your specific goals. If you're managing a research project, for example, like the example we were giving before, it might be better to have a lead agent organizing the work and delegating the tasks like data gathering, analysis, report generation. On the other hand, in more dynamic situations or scenarios, you'd have real-time decision-making or creative brainstorming. A peer-to-peer system might allow agents to interact more freely with each other without the sequential hierarchy. And they'd be able to kind of share more insights on an equal footing.
Well, that sounds very interesting. So you mentioned several workflows types, and one that interested me a lot is when you have a kind of supervisor that will orchestrate the works of other agents. Now, my question is, can this supervisor be human, like rather than an AI agent? Can we have a human in the loop within these workflows as well?
Yes, of course. And I would suggest that, at least in the beginning, to have a human in the loop. So you're kind of ensuring that your agents are responding accurately. Again, they're not hallucinating. It's also nice to see, you have the agent generating something for you, and then you have the human edit that. So I think it's always nice to have a human in the loop.
And as we mentioned before, this is also a way to reduce hallucination, right? So to avoid like the overproduction and overconfidence that models can take when left alone. So we covered different workflows and examples of flexibility that you can have while building your crew of agents. Now, Lana, could you share with us some real-world applications of these multi-agency frameworks?
Yes, of course. So I shared before, a research assistant or a research agent. You can think of other examples as industries like healthcare, where one agent is retrieving patient data, another agent is analyzing the medical history, and then you can have another one that's generating a treatment plan based on the case at hand. And in this architecture, all of these agents are working together seamlessly.
And the cool thing here is that there's plenty of libraries and frameworks out there when you can start building your own multi-agent system or framework. To name a few, we have AutoGen, QAI, or LangGraph. This latter is very interesting also because it leverages the graph structure as underlying architecture for multi-agent systems. So very powerful and very promising for the future.
Yeah, so I like the idea of graph structures. If you have documents that have a lot of relationships, you can kind of leverage something like LangGraph. But I guess if you were to we talked about a lot today in such a short amount of time, and I think if you would just remember the key ingredients to building your systems are really defining clear roles for each agent, setting up effective communication between them, so whether that be sequential or have them all equally participate, and also choosing the right framework to support the complexity of your tasks.
Well, thanks a lot for sharing your perspective on this topic. To be honest, I'm really looking forward to seeing some applications of this framework in industries. And given the pace of recent achievement in this field, I have the feeling that we won't wait for a long time.
Absolutely. I think with the speed of which AI is evolving, we'll be seeing multi-agent systems becoming much more mainstream sooner rather than later. And I'm really excited for this innovation. It's really an exciting time.
That's so true. And sometimes it's hard to keep the pace, but luckily we have TechStation to come and share as much as we can. So with this last self-marketing advertisement, we can wrap up this episode. Thanks a lot, Lana, for joining us today. Your insightful experience is very valuable, and I hope to host you in the future soon. To all listeners, we hope you'll join us for more to come. Thanks for tuning in, and we'll see you next time.